Okay, make sure we're still recording. And we are, so we're good. Okay, 32. This one is the same problem. I just want to go through it again. But I want to use a tool that I have not talked to you about, I don't think. Have you seen this? Have we seen this tool? No. Okay. Look at your reference sheet. Look in the upper left corner. You will see in the upper left corner a table that is not quite as complicated as this, but it does contain the same information. Like your table looks kind of like this blue box. Your table has a typo you need to fix. The D on the table right here, yours accidentally has an I, so change that to a D. So fix the typo right now. Fix that typo. Should be concave down means decreasing. So just like the one on the board, fix that. Okay, this table is a 20-year tradition in my class. It is not something you'll find in a textbook. You will not find it on Google, like on the internet, because it was created by a student. Her name was Danica Wright. There's a picture of it on the wall over there. And what she did is she took what we were talking about now, and she just kind of consolidated it into this nice table form. And it turns out to be an extremely useful tool on about, well, I don't know, 15% of the AP problems you'll encounter. Like you'll use Danica's chart. Super helpful. So anyway, you have a copy of it now. I give her credit for creating it because she did. I didn't create it. Here's how I would use it. I look up at F. I could do Josie's method. That's not bad. I could say, hey, right here, the slope of F at x equal pi must be 0. Therefore, down here on F prime, the y-coordinate of F at x equal pi must also be 0. That would immediately eliminate those two. That is a really good way to start, for sure. Well, please.
Wait, why would it equal 0?
So if I look up here on F, and I'm trying to draw F prime, two more for Ellie, I'm paying attention to the slopes of F. So I note right here, this slope here, Ellie, positive or negative?
Negative.
Cool. This slope here, Ellie, positive or negative?
Negative.
This slope here, Ellie, right here.
So it's like 0.
Yeah. That didn't work out very well. I thought I had it. So this slope is called 0 because if you could somehow zoom in on the dots, you find a dot here. Like if we could do this little trick over here like in Desmos, where we move the dots. If you move the dot right to the bottom, right there, like, come on. It's not gonna work. There we go, like that. Then you make the other dots closer and closer. The two secant slopes get closer and closer right here to actually being the same, and they both get closer and closer to 0. That's because the slope right at that bottom point is 0, because those two lines are getting flat. That's your question.
Yeah.
Okay. Other questions? Okay, look. So we okay that A and B cannot be the correct answer. Awesome. Here's how you can now use Danica's chart. You could say right here, the y values of F are going down all the way to here. The y values of F are decreasing. Okay, F prime means the rate of change of F. So if my values of F are going down, that means they are changing at a negative rate. They're getting less and less. So Danica's chart summarizes that. It says if F has y values that decrease, that means the values of f prime must all be negative. So in this region, from x equals 0 to x equal pi, where you see the values of f decreasing, you would have to find an f prime graph where the values of f were all negative for that entire time. So we're down to choosing either C or D. Hands up, who knows which one is the right answer? There we go. Olivia, which one? So D has y values that are strictly negative from x equals 0 to x equal pi. So x equals 0 to x equal pi, the y values are negative. That corresponds perfectly to the fact that f must be decreasing in that span. So that would tell us D has to be the right answer, because over here it's wrong. The y values over here are positive. That would indicate f must have been increasing. F is clearly not increasing. So that's why we would choose D. Questions? Oh, please.
So the slope of the f of x, is that equal to y coordinate of the f of prime?
So what Ellie, sorry, 1 second. Anna, sorry. What Anna just said is right here. And there's a note like that on your reference sheet right inside this box that says, come on. Close. So right here it says every value of f prime, that means every y coordinate of f prime, is a tangent slope on f. I think that's what you just said. More, Anna. Somebody else? Oh, please.
I like kind of understand why, but why on the answer like D does it like curve back up, but it's still negative? But why does it have like a positive slope?
That part is not easy to see. So I'm just going to have to say be patient.
Okay.
Yeah, it's a really, the question is valid. It's just not a quick explanation.
Okay.
So we'll just have to let that one sit. So sorry about that, Lizzie. 2 more. Anybody else? Okay. I need to point out something else with Danica's chart. Look. Okay, right here, you should have, I'm assuming you talked about this in your previous class. Okay, hands up, everyone. Would you say that red section of F has concave down curvature or concave up? Say concave down or concave up. Say it. Okay, so everybody's got it, right? Concave down. Look at me. Okay, I don't know if you were told this previously or not, but you do need to memorize, and it's in Danica's chart to help you. The word concave down means the slope is decreasing. So this F is concave down all the way to right there. At that moment, F changes from being concave down and switches to concave up. While F is concave down, if we check the slopes, so Lincoln, Pei will help me. So Lincoln, the slope right here, positive or negative? Negative. If I go to the next slope, positive or negative?
Still negative.
More negative or less negative?
More.
More negative. How about this one, Lincoln? More negative or positive?
Negative.
More or less than the previous?
More.
More. So the slope is becoming more and more negative. That means the slope is decreasing. Danica's chart summarizes that. It says if you have a graph of F, and you know that graph has a concave down shape, that means if you look at the values of F prime, those F prime values must decrease. They must go down. That's why right here you'll see that happening. These values of F prime are getting less and less. That corresponds perfectly to this section of F. This section of F is concave down, therefore these values of F prime must decrease. That's also in Danica's chart. Okay, that might have been related to your question.
Yeah.
Oh, very good. Two more. Anybody else? Please, I misunderstood your question. Apologies.
Is there any question where you need to use both to solve it? Because we could only we solved it only using like increasing and decreasing. We didn't use concave down.
Two more for Kai. What I've noticed over the years is that a good number of AP problems that are looking for some sort of match can be done in multiple ways. It just depends. So I'll try one method that might, reduce it to maybe two possibilities, and then I'll use a different method to figure out the last two. But sometimes one method is enough. Just depends. Anybody else? Okay, one more thing. Okay, f double prime just means the slope of f prime. F double prime just means the slope of f prime. So we know that for this situation, the correct answer is D. D is our correct f prime graph. So this is the f prime for this f graph. Everybody good there? Okay. Let's see if it works. 1 second. Yeah, it doesn't work. If you were to take this f prime graph and then do the same analysis again, you could figure out what the f double prime graph will look like. For example, look here. When f prime is initially decreasing, the values of f double prime will have to be negative. So right here where f prime is decreasing, if we were looking for a graph of f double prime, the appropriate f double prime graph would have to have only negative values in that region. But then when f prime switches to being increasing, that now means that the values of f double prime would have to switch to being positive. So I was trying to see if one of these two was possibly f double prime. They do that sometimes to get you off track, but neither one works. When f prime is decreasing, f double prime would have to have negative values. This is good so far. But then when f prime switches to increasing, f prime would have to have positive values. This is now wrong. That doesn't work. So
what would f double prime look like?
are they looking at me? Good luck. I have to confess, I'm not really good at the graphing thing because they don't test you on it. So I will do my best, but I will probably apologize a lot as I do it because I'm not very practiced because they don't ask us to do it. But f prime decreasing means f double prime has to be negative. Maybe this would be a better way. Just think of this column as being f prime and this column as being f double prime because it works either way. Like f relates to f prime in exactly the same way that f prime relates to f double prime. So if I'm trying to look at an f prime graph and draw f double prime, it's just using this section of the chart works great. I could say, okay, right here the slope of f prime is 0. That means the y value of f double prime would have to be 0. So I put a dot here. I put a dot like here. This is at pi over 2. This is at 3 pi over 2. That's probably where I'd start. Any questions to there? I'd say when f prime is decreasing, f double prime has to be negative, so I know I'm down here for this region. When f prime is increasing, f double prime has to be positive, that's up here, and back to negative, so I know I'm down here, up here, down here. It's probably just going to do this. Like that. So it just went back. That happens sometimes, it does not happen all the time. So. Oh, please. Oh.
So like the negative side of the graph and the positive side have to have the same slope?
I don't know which graph you're talking about.
The prime graph.
So you're comparing f prime to which?
Like, I'm just it's like on the B graph, it eventually goes to be positive, so I'm just like,
Let's kind of wait on that for a minute. We'll keep practicing. Two more, please.
So for F double prime, our zero is always going to be the same as our original F graph.
No, just coincidence. Yeah, not, for sure not. Two more. Okay, other questions here? Let's keep practicing. So stop this video. It already stopped. Lost my points up here. There we go.